Desde atrás no me ven.
Okay, well, thank you everyone for coming. This is the first Edinburgh School of AI meetup, and we're really happy that this has found so many of you already through meetup, through word of mouth, or however you hear. So, thanks for that. Just to introduce us a bit, this is Faisal. He did a master's in data science, and now he started to work at RBS. And I myself am Stephanie. I'm doing a PhD here at the School of Informatics, so we're trying to represent the professional and the academic side of things a bit to bring together different kinds of people. And we hope that this will be a learning experience for all of them.
Yeah, so as Steph said, my name is Faisal. I'm a data science professional now after I finished my master's. And yeah, thank you all very much for coming and for being here today. We have a full house, and we're ever delighted to have two amazing speakers. Mercè traveled from Barcelona to be here, so thank you for coming.
Can you stand up for a second? Oh yes, I can see you.
Hi.
And yeah, we are a little bit tight with the schedule, so without any further ado, I'd like to introduce Joa, who is going to speak to us about big ML and how we can automate machine learning workflows. They both have a PhD in physics, so I think they can teach us a lot about modeling and life events in general. So please put your hands up together for Joa.
Thank you for coming. Thank you, Pastor, and thank you, Stephanie. It's been great to be here and try to explain what we are doing. Let me start. By the way, I'm sometimes difficult to understand, so feel free to interrupt me. Feel free to ask, to stop me. Us, about BigML, about what we are doing here, and why are we talking about machine learning as a service, and why would you be interested in listening about machine learning as a service, and then talking about the challenges that we found when implementing that, and the things that we expect you to expect from your providers, not only BigML. In Corvallis, where we started, we have offices in Valencia, and I moved here recently because we are thinking that if we get traction, it will be nice to have also offices here in Edinburgh, in Scotland. And what we've been doing since 2011 is narrower and different in ways I will explain. But then, so we started, this was a startup. We believed in what we were doing, but we had little proof that it will work. But what happened, and that's why we are here today, I think, is that other big companies over the years have also started doing this thing, this machine learning as a service thing. So yeah, we feel that we are in the right track. So, and also we feel that we have some experience doing that. It's been already 7 years. So, and why do we think that machine learning as a service, we all, not only BigML, but also Google, also IBM, and all these guys probably, you too, why do we think that the machine learning as a service is something that we need, or to begin with, what it is? What do I mean by machine learning as a service? Well, it's an old story, right? You all come from computing, so you know this story here, how we started abstracting hardware. Suddenly, with operating systems, we didn't have to care about how our computers were built. Like, you didn't talk to the hardware anymore. You had an abstraction layer there, the operating system, and we kept doing that. We decided that we wanted databases. We wanted a way to abstract away the complexities of dealing with data, of performing queries. You these days use databases using SQL, and as a developer, you don't know anything about indexing data, about putting it in disks, about distributing it in different places, making that fast or slow. You just perform your queries, right? You have an abstraction layer that lets you stop thinking about implementation of databases, stop thinking about algorithms, and start thinking about your problem. Start thinking about your queries and about your solution. You've gone to your domain. And same thing with networks. Same story. You don't even know, at least I don't know, the nitty-gritty details of TCP/IP, of how a network works. And even if I know, I don't need that in order to use a bunch of computers here in my local area network as if they were one. I just program against a lawyer, an abstraction lawyer, an abstract interface. And something interesting, this was the 80s, 90s, then internet came, and something interesting, very interesting started to happen by 2010, a bit before maybe, when we started talking about cloud services. And the interesting thing that happened there is that for the first time, our abstraction layer was remote. Suddenly we started having services like Amazon, services that don't live in my local area network, that don't live in my computer, but that live in some server in the internet, far away from me, or I don't know, I don't even care where. Okay, it's a distributed system. I talk to an endpoint there, and I have an API, I have an abstraction layer that now it's there in the cloud. And so I can do things that are novel, like I knew how to manage a local network. Now I can manage, or I can use a big cluster of computers. And I don't even know it's a cluster of computers. I don't even know how in Amazon all these instances are working together, when a new instance is created to help me in doing my computation, when that instance goes down, and so on and so forth. I just use the service. I just use the API. I got this nice abstraction layer. So yeah, we had suddenly all the ingredients that we wanted for a new one, a new abstraction layer. To us, and to many people in the industry, it's now clear that machine learning should be just like using machine learning should be a tool for you to solve your problems that you can use as you use a database or as you use the distributed systems abstraction layer there. It should be a tool for you, and you shouldn't need to be aware of how it is implemented, of how those algorithms are working, and also of how we are scaling, because the thing with machine learning solutions is that you need lots of resources sometimes. So can we abstract that and you forget about that and you just do machine learning? So that's what we are trying to do. I would say what we are really doing, we are converting machine learning in a service that has all these properties here. It's accessible. You know, you all know what that means. I can use it from anywhere. I can use it. I have to have the ability of using it from here, even if I don't have a network connection. It must be integrable in any device and also in any service. Like, if I want to use a database, I can use it anywhere these days. I mean, you won't use a service that tells you, no, we don't have databases. So machine learning, our service should be like that. It should be like, okay, I want to use machine learning. I want to do that also from anywhere and integrate it with any other solution. It should be, therefore, automated. It should be easy to automate. If you've done machine learning and solve problems with machine learning, you know very well that very quickly, you need to combine different models, different operations. You start creating workflows. You want to do complex things very quickly, and you want to have ways of automating that, of repeating that, of doing it over and over. That's what you do with any other problem solution or way, in any other way of solving problems in computer science. You've got automation. So we have to have easy ways of automating things. And with all this, we have to keep, if possible, and whenever possible, ease of use. Remember, I want machine learning to be used by people that are not experts. So we are trying to provide all these nice properties without losing, when possible, ease of use. So this is what we are going to try to do, and this is our goal. We want machine learning as a system service. And we are going to try to do it using APIs and putting abstraction layers over the operations that you perform typically when you are doing machine learning. That means abstracting algorithms, abstracting feature engineering, and providing good automation. And we are doing that, as I mentioned, not only by creating an abstraction layer, but by providing that abstraction layer by means of a remote service, of a distributed remote service, something like a cloud service. And how do we do that these days? Back in the day, people were using, when you were using learning distributed systems, everybody was talking about RPCs, and the transport was done in XML. Maybe you look too young, but
Some of you may remember enterprise Java beans and all those protocols. It was all very complicated. We've evolved from that, and in recent years, we discovered simpler ways of talking to servers, to remote servers, of having APIs. I'm sure you are familiar with the REST paradigm, or the REST way of doing things on top of a transport, a data transport layer that's JSON, that is so simple that it looks silly at first. At least I remember that was my reaction when I first saw JSON, like, this is not going to work, it's too simple, I need more complexity to express what I want. Well, it turns out that, no, I don't. That it's simple, but that's what makes it powerful. Moreover, it's something, this JSON thing is something that lives in all computers in the world. It's like, it's the lingua franca of JavaScript, or we have browsers, that's what we use. And what those browsers understand natively is JSON. So it's the good data language for expressing the interactions with this new service. And on top of what? On top of an HTTP server, of an HTTP protocol that it's also so simple that at first it might feel as insufficient, and it turns out that it's just what you need. And you only need 3 verbs. You know that you can do a post to create resources, you can recover them with a get, you delete them, and you can also modify them. But you'll see that we don't really do that. For reasons I will explain. So in the end, most of your interactions with this remote API, with this machine learning engine, is built on top of 3 verbs. So, and on top of a very, very simple JSON language. So it's really nice and simple that we can build on top of that. Or at least we are going to try, and I'm going to try to convince you that it's working. Just a quick note is REST, this interface that we are building is REST this. It's not really pure REST because it has a glitch. It has, like in REST, in an ideal world, you do a post, you create your resource, you get back a handle for that resource immediately, and you are done. And then you can start using it. When you are doing machine learning, when you create a model, when you create an anomaly detector, when you start a process with one of these complicated algorithms with lots of data, that thing is going to take a while to finish. These days, it's like minutes. But if you have gigabytes of data, well, terabytes of data, maybe it's 2 hours or even 1 day. So your REST resource, when you create it, is something that is in progress. It's something that is not finished. It's something that you can start using, but just to be aware that it's evolving. So that's a modification of the ideal REST world. But we live with that, and it works most of the time. Things evolve, and you can use them at any time until they get perfect, and then you continue using them, or you can wait until the end. And the only problem with that is that sometimes things fail. Sometimes you get an error at the end, so you have to you have to be aware of that, and especially when you are on the client side, things seems to go well, but you have to be aware that things could go wrong. In a pure REST system, that's not a concern. In a pure REST system, you create the resource, you get either an error or the resource, and you got the resource and you are happy. Here you have to look at the future a bit. Okay? Okay, let me. So is this enough to really have a machine learning service, to really do machine learning, just these resources? Let me do a very quick demo. So we have a platform that does just that. So I'm now going to use a browser, and this is connecting to one of these services in the cloud. And this is going to use only HTTP, and it's only to use only JSON. And on top of that, it's going to do machine learning. Since I guess that you know a bit of machine learning, I won't enter in details, but I will show you things that will look familiar, how machine learning works in this world. First thing, I need data, and I'm interconnected. I need connectivity with wherever the data is. So first thing you have to ask from your machine learning provider is that it's able to grab the data from wherever. Here, let's say that you see that I have many ways here. Let's use a URL to a data set. I'm not using Iris because it's so boring. I mean, everybody uses Iris for machine learning. So let's use So this is data that lives in the web, and I'm going to import that in my service. So this is just create a source of data. So I'm doing a post, and let's call this charm, and and I'm creating a source. This is just going there to whatever it's in the URL that I gave it, and it's going to download the data, and it's going to look at it and tell me, oh, I see all these fields, all these columns, and some of them are text, and some of them are numeric, and some of them are categorical. So that's one of the things that abstraction starts a bit here. I'm not programming. I'm not telling the system this is a number and this is a category and this is blah, blah, blah. The system is trying to guess for me, and it's doing its best effort. And if I'm happy, I'm going to ingest. This is a preview of the data, and then I'm creating the data set for real. I'm just ingesting. You see there the progress. So now we are really creating the resource. We are really ingesting the data and analyzing it. This is not yet machine learning. It's just basic statistics. You have here, what I said, basic statistics, histograms, distributions. I have my data ready for machine learning. And all that I've done here is creating JSON resources. And I can go, and so these resources, we don't see how was it? Here. See in the browser? So this is just a URL. And all the browser is doing is downloading that URL. And I have a unique ID, that's the resource ID, and from now on, there's something in the world that has that unique identifier and that I can use. That's my resource. And that resource, you can see here is a pretty representation, but that resource is nothing else than JSON. I can go to that URL, give that identifier to the system, and ask for the JSON. And this is just the browser showing JSON. There's no post-process, there's nothing. So I already have a resource describing my data that is usable from anywhere that understands JSON, but everybody understands JSON. So it's all this transparency thing. I'm just manipulating JSON resources. And so when I have the data set, well, you know that you can start making models, but you know that you don't know, you don't do models directly, predictive models, for instance, or unsupervised models. You don't know modeling directly over all your data. What you do is you split your data in a test set, in a training set, so that you can evaluate things, right? So, yeah, you could expect, you have to expect from your service that those common operations in machine learning are there and are easy to perform. We are trying to abstract things. And this thing that I'm doing, which is again creating two resources from a single one, is just doing two post requests, and it's creating two halves of my data set. Well, it's not half because I'm putting 80% for training and 20% for testing. So I will end up with two data sets. And this is a sample of the data set. It means that it's statistically sound, it's random. So it's not that I'm just taking the first 80 and the last 20 rows. It's sophisticated as it has to be. But you don't need to know that. You just do the split and trust that the system is going to do the right thing. It should be doing the right thing because we are abstracting over machine learning, not over data generation or whatever. So it should know. So what I've done here is I've created two data sets. If I go to the listing of data sets, you see this is the original one, and these are my two halves. So I'm taking the bigger one, and I'm creating predictive models. And that, again, should be easy. And here you see I can create a tree. I can create an ensemble. I'll go briefly. I can create a logistic regression. I can use deep nets. Deep nets are deep networks. So we can create them also easily. I can create something that's optimal that I'll come back to that because that has to do with automation. And I can also do things that are unsupervised. I could do an anomaly detector, I don't know. And so the things are working here. They are evolving. They are being created. Most probably the tree is already there. Yeah. I created, this is one of the models that I've created. This is my data. This is a decision tree. Everybody knows what a decision tree is? Yeah, we're familiar with that. This has just gone to my data and tried to split it in categories. So this data set has a field that tells me see charm there. This data set has a field that tells me if a customer, each row is a customer, and the last field tells me if the customer did abandon the service or not. That's charming. If charm is true, the customer, which is a subscriber, who is a subscriber in a telecom plan, did abandon the service. If it's false, he or she didn't. And of course, what I want to do with this data is to be able to predict next customer is going to charm or is not going to charm. So there's a field that the system chooses for me naturally. I can, of course, configure everything, but the system is clever enough to know that I want to predict charm because that's the last thing. And it's giving me a model that does precisely that, that tells me when a customer is going to charm or not. And it does that by giving me a set of rules, a set of questions. You ask the questions on the right. So you know data about, these are fields that you know, these are values about your customer that you know how much you charge her, how many times she called the service, how many international calls she is doing, and so on and so forth. And for each one I have a threshold, and if all these conditions are true, I can predict that she is not going to charm. Of course, there are other places, if I can find one here, where she is going to charm. So this is a predictive model, and it was built for me by the system, and again, this is just JSON. I can use it wherever. What you see is a nice picture, but all that there is this data, is in the data, is there. It's there. There's no magic. You can look at it, you can analyze it. Everything is there. So this is my nice predictive tree. Then once I have the data, which is so transparent and so easy to represent and to manipulate, I can do things like representing it in different ways, like in a sandbox. This is the tree looked from above, and then you look at the confidence. Because also, as you know, a prediction always comes with a probability, always comes with a degree of confidence. And any model, any predictive model is going to predict something, but tell you also if this thing that it is predicting, is it predicting it with confidence, with a high probability or not? So here you see that this tree believes that it is predicting with high confidence. But should I believe that? That's only telling me that over the data that it's seen, that the model has seen, this 80% of the data, what this is telling me is that the model is confident that if all the data in the world is like this one, it will perform well. But you don't know if all the data in the world, if new customers are going to be like these ones. And that's why I kept a 20% of the data set to test my model over data that it hasn't seen yet. You know that that's a normal procedure called evaluation. And again, that's something that my platform, that my remote API, that my machine learning as a service has to provide me easily. And of course, this is again HTTP. This is again create for me an evaluation. I took the 20%, I took the model, I get an evaluation. Okay? And I get a full-fledged evaluation. You need everything. You need, this is going to be easy to use, but you experts need to use it too. So I have to provide everything that an expert needs. How many people know what ROC curve is?
Rock curve.
Rock curve. Ah, you say rock? Okay, sorry. We also say rock. But okay, these are like for those of you that don't know, these are more advanced ways of calibrating whether your model is good or bad, of knowing whether your model is good or bad. And also, it gives you a way of using your model better. Because as I said, when the model says, this is going to be charm, this customer is going to charm, it gives you a probability, like with 20% probability or with 80% probability. And then you can decide, I'm only going to believe the model if the probability goes above some threshold. That's what we call sometimes the operating point. So this allows me to play with that operating point, with that probability, and it's telling me how when I change the probability, the thresholds, the model is behaving. So all you need to know is, by now, is that the area under curve here, if it's big, if it's bigger than 1/2, things look good. And there's always a point here that is the best one. It is the one that we are selecting here. So when you evaluate your models, you not only know if they are good or bad, you also know the best way of using them. So, and all these things are just JSON working against a service. And you don't need anything else. So things are working well, and I could go on, and there are many other algorithms there, and you can do clustering, and you can do anomaly detection, and lots of things. And those are the things that you should expect. And that's, I think, the level of, but at this level of abstraction, I was not worrying about where the models would finish, if there were errors, if the algorithm was going to converge or not. I just asked for something and waited and then analyzed the result. Just like when I do an SQL query, I wait for the result, I get the result, I look at that. So that's the level that I want. So are we happy with all this? Are we done? This is, again, the nice properties that we've seen that should make us happy. We have all these. I've seen every of these things more than once already. And these are all things that are good, that I want to expect, and that this API, is this mode of interaction is giving me. So we can sum up things saying that all the complexity associated with algorithms, all the complexity associated with handling computing resources, we don't know how many computers in Amazon this took. Maybe we had to start 3 instances, I don't know, or maybe not, but we don't care. We just computed things, and they are there. So all those complexities, all that complexity was away. I don't care. I'm happy. I go on solving my problem, which is not about creating the model. It's about using the model. It's about telling my customers what they have to do in order for them not to charm, or something like that, right? So a very important thing, and I think that's fun, is that this is RESTful done right in the sense that you saw all the resources are white box. There's no secrets. It's your data, it's your model, it's your JSON. You can use it wherever. And that's key for interoperability. Back in the dark days, when you had the Google Prediction API only, you send your data there, Google was creating your models, and then when you wanted to make a prediction, you send your data there, and you got back a prediction. And you didn't know where it come from, why it was so, anything. There was no explanation. That's like black box machine learning. And we started from the beginning doing white box, because moreover, when you had that white box models, you can download that and do things everywhere, like in Alexa, for instance.
Ask BigML to load the latest model.
The latest diabetes model is loaded. BigML is ready.
So
Make a prediction.
We can integrate with an Alexa.
What is the patient's 4-hour plasma glucose?
So it's not only my voice.
180.
What is the patient's body mass index?
35.
What is the patient's diabetes category?
1.
The prediction for diabetes is true, with a confidence of 91%.
So that's what white boxes give me, the ability to integrate. And that's something that we need and that we have. So any of you could program that Alexa skill and keep on with your business. So we should be happy. Are we happy with all this? Are we done with machine learning? Well, we would if this was just an ideal world. This is the toy machine learning workflow, no? In the textbook machine learning workflow. You just have your data, you prepare it, you put it into an algorithm, okay, then you can predict. You can use your trees, you can use your clustering, and you do predictions. But of course, real life is not as easy. We have already done something, a small workflow in my demo. We had to start with a data set, split it, create a model, then evaluate the model, then use it. And if you start working, yeah, well, you all know when you start working and doing things, things get complicated. Then, for instance, you start combining non-supervised algorithms with supervised algorithms in order to clean your data and then create better models, or in order to know where you have to remodel things. I don't know, this is a typical algorithm, which is still, or workflow, which is still very basic. These are the first things that you do when you start using these things for real. And so you see that things start quickly to get complicated. And we were predicting churn. This is an example from the Microsoft Azure team of how they are proposing to predict churn in a real case situation. It's just to give you an idea of how complex things could get. And once you get to these kind of workflows, how do we program them? Are we still happy with our model? Are we still able to be just like abstract and automated and what we just did with a single model? Can we copy that model, that way of operating to these complex workflows? Well, when one wants to combine different things together, and that's one of the powerful things of APIs, the first thing that one does is to go to the client side. I'm talking to the server. I'll take a programming language, the one that I like most, whatever, because since the interaction model is so simple, since HTTP is something that any programming language, even COBOL, knows how to do, and since HTTP is so easy, it's very easy to create a library on the client side that knows how to talk to the server and knows how to do those operations of creating data sets and creating models and creating ensembles or whatever. It's easy to program. So you think, okay, I have to combine all these operations together. Okay, let's take a binding for a language, a library that knows how to talk to the server, which is moreover open source and it's maintained, and we have them for all languages. And even if we don't have a good one for one of the languages, you can improve that because these are open APIs and people contribute. And again, the protocol is so simple that you can. It's easy. It's easy to provide your new library for your new binding, and then you start creating your workflows, writing your instructions. Right now, do this. Now do that. Now do that. Now do that. But is that good enough? Is that what we had with when I was creating here models? Clearly not, right? Because things get hairy very quickly when you start using your programming language. Things get complex because when you are using Python or R or whatever to talk to a server, you have to start worrying about network problems, about errors. You have to start waiting for things to finish and then coordinate them. You have to start worrying about scalability. What if I want to create 100 models? Should I do them 5 by 5 or in parallel? And if I'm doing all in parallel, is my computer enough, or do now suddenly need on my client side a cluster? Do I? So suddenly all these nice things that I was saying before, that I don't have to care about the clusters of computers. I don't have to care about problems. I don't have to care about algorithms. Now they're coming back to me. Suddenly I start programming and I have all these problems back. And another big one, reproducibility. Like the moment you start working with your favorite environment, local environment, and then you go to a bank or to someone that needs auditing of their processes and tell them, no, I created this model with a bunch of scripts that guy there wrote in his computer, and then you go to the other computer, oh, but this doesn't work. No, it's because I had an environment variable defined. Wait, I'll put it here. So things get noisy, and that's something that you don't want from a service that is going to be used for heavy duty tasks like predicting cancer or in banks or things like that. So things are getting not as nice as we had them. Summing up all that I said is, we are lacking abstraction again. We don't have enough abstraction with this. And a first try of solving this, a problem, part of the problems of what I've said is that I'm back to saying to the system how to do things. I have to program my workflow and tell it, first do this, then if this goes well, then do that, then if this is as this and as that, then do that. So I'm going back to algorithms, I'm going back to step-by-step instructions. So a way to avoid problems would be to be declarative again. What I want is to tell the system, solve this problem, and this is the spec of the problem. Do whatever you need to solve it, right? As I told the system, this is my data set. I want to predict using a tree. Do whatever it takes. I'm not telling you how you should compute the splits in the tree. I'm not telling you anything of that. I'm just exposing the problem, being declarative, and then asking an answer. So from the client side, we can try something like that. We can create tools that use the bindings, use all this complicated stuff behind the scenes, and that gives us answers. Like I could say, okay, I want to create an ensemble. This is my training data. This is the number of models in the ensemble. These are all other parameters of the ensemble. This is my project. Give me back my ensemble. Do whatever is needed. I know how to do that generically, so I can have a template and then do that. Or I can do more complicated things like training, or like even cross validation, which is a typical workflow that I want to do. I don't want to do only one evaluation. I want to do many and then average over them to really know if my model is good. That's a typical workflow that I can program it once, put it behind a command line tool or a client-side tool that only asks me, oh, how many data sets you have, where are they, and where do I put the results? And I'm solving part of the problems that I had a moment ago using bindings, using Python. Because, well, this is simpler. I'm talking about my problem. It seems to be working. Of course, I'm not yet happy because, yeah, you see that this is nice, but I cannot automate everything like that. It's not flexible enough. The moment you have a workflow that is not pre-programmed, you won't know how to use it. You won't be able to use these tools. And also, these tools that do full things like a box, like in one step, are difficult to combine. And then combining is key to automating because you have partial solutions and you want to put them together. So I'm not yet happy. I have these problems with client-side workflows. All these problems here, and the key here is the summary is that this nice thing that I had with my REST resources of complexity and computing resources management washed away, not a problem, and they are back. I have those problems again. So what to do? Well, what I just did to solve my first problems about creating models, about creating evaluations, and make the world a nicer place was inventing resources there in the server that were black boxes working for me. Like the workings of the resources were black boxes. The results were white boxes. So I'm in this situation. I've done everything I could going on the client side for automation and for abstraction. How to do better? Well, I'll go back to my resources. I had to find a way of putting the automation, the abstraction back in the server and transfer it to a resource that lives in the server and that gives me all the nice properties that I want. And the way of putting a workflow that is a declaration of intentions, is a set of instructions to the machine to do something, is to create a domain-specific language. A language that talks about machine learning and only machine learning. I don't want to talk about connections to the network. I don't want to talk about, I don't know, reading files from the disk. I want just to talk about machine learning. So I want a language that can express workflows and only workflows at a very high abstraction level. So that's why I will use a domain-specific language. In our case, we are calling it WSML, but whatever, and it will have its syntax. But any other service that is providing this kind of service should give you something like that. So these are the two key ideas for simplifying life, for being happy again. Reify your workflows, make them RESTful, resources and use a domain-specific language to express them. So yeah, if you've programmed, you already know. I mean, if you want to create resources to do procedural things in a server or whatever, you want to have code that you execute. So you have scripts, which are the code that you execute. You have executions, and then you also want some kind of library to reuse code. So nothing very strange here. The only nice thing is that, or the only special thing is that all these things are resources, JSON resources. And I'm going to represent them in the system as JSON resources, just as any other thing. So I will have scripts, and here you have a script, and a script will have inputs. And this is again, let me show you quickly. This is again a resource. So this is again JSON. This is again something that I can download, I can use. It's a resource, and that I can combine with other resources at will, which is really powerful and is really what I need. And once I have a script will have inputs, just like any other. Let me choose here. Sorry, the channel. So this is a script. We'll have input, so it will start with a data set. It will have code. This is the domain-specific code that I was mentioning. I'll go back to that in a moment. This is just to show you that then I can execute. So I started with a resource that's a script. This is an execution. See, it's a resource, one of these REST plus resources, because it's something that is evolving in time, and it's something that is producing results. And in this case, it will produce other resources. But it's not really that different from a model that was evolving in time and in the end giving me answers. This is just a new resource, an execution that's evolving in time, and in the end giving me answers. In this case, in the form of other resources. But I'm using it just as a model, as a data set. I'm creating it in much the same way. And again, this is JSON. You can manipulate it. You can explore the results here. You can visit all the things that I've done. By the way, this is just the workflow for creating, splitting the data set, creating a model, and evaluating that, so that I don't have to go every time and create it here, click by click. I just do it once, I codify it here, I'm done. So this is the first idea, and the second idea is that code. How do I express my workflow? What I want, this is the code for what just I did, and you see, this is very this is talking a bit JSON, but in an stylized way, like as simple as possible. We don't need columns, we don't need commas. Okay, let's make it easy, but also very easy to map to the JSON world, because I'm going to manipulate resources here. So I want the language to be parallel. If you have, for instance, if you have to manipulate maps, dictionaries in Python, it doesn't look syntactically at all like manipulating JSON. So we have this is one of the reasons that we are creating a domain-specific language, to make the manipulation of data, the data structures that we need, natural in the syntax of the language. And you see here that, I mean, even if you don't know how to program in WSML or what WSML is, I think it's pretty clear that we are splitting a data set here, that we are creating a model with one of the data sets, and that we are creating an evaluation using the other half, the test ID, and also that model. We are evaluating the model with this data. And that also, if you are familiar with the API you're talking to, you know that when you create evaluations, you can give them names, you can use missing strategies, you can parameterize your process. And note that this is production level code. It's going to run in the server, so I don't have to care about errors, I don't have to care about retries, I don't have to care about resources. This is going to work with any programming language, moreover, because it's creating a resource. So I can call it from my bindings, from my client side. I can use this in Python to run the workflow. And this workflow could be as complicated as you wish. Could create hundreds of resources, millions of resources, and take lots of parallel computers running at once. And production code to run that script on my client side is this simple, in any language. In any language. So I don't have to program, if you are programming in Python, this super complicated client-side thing, and then go to the next company and they are using R, you have to reprogram it. So this super complicated thing, programmed in a domain-specific language, in a server-side workflow, it's trivial to port to R or to whatever other language your new company is using. So that's one of the things that we are gaining to. And the other thing is that we can adapt the language so that it's easy to optimize. And so with the minimum fast possible. Like here I'm creating something that's a batch centroid, that's a resource that uses a data set and a cluster. And then, okay, this is easy, and you say, okay, I can do that on the client side, this is easy. But what if I want to do this 1,000,000 times? Like instead of one source and one data set, I have 1,000,000 each. If I'm on the client side, I got lots of trouble, lots of questions to solve, and my code is going, if it's going to be really production grade, it's going to grow bigger because the problem is much more complex. But when we put this workflow on the server, we are solving all those problems on our side, and all you need to do to tell the system that you want to scale this to 1,000,000 data sets is just tell the system that, but tell that without any complexity. You are not talking about computers, about parallel threads, about anything. You just create a list of data sets, a list of clusters, and then use one of our nice functions, map, that will do the single operation over these lists as optimally as possible, caring about the starting threads and starting machines and recovering from errors and whatever. You went from 0 to 1,000 just changing 4 or 5 lines. And this is again production grade code. So we are good. Another thing that I'm not going to show you because I'm late, but that's important and that's nice, is that once you put your workflows as resources in the system, what are your workflows doing? They are manipulating resources. By the way, my scripts, my executions are resources. So I can have workflows that manipulate other workflows. I can have a language that create new scripts. So I can have meta-programming. And a nice example of meta-programming is Scriptify. So when I'm in the web and I've created this, I cannot help it. I created this evaluation. You remember I created one evaluation, and now, hey. I've created, for instance, this evaluation. I was following a workflow. I was doing a series of steps, but the system knows the parent of this guy. It's a data set and it's a model, and it knows where it comes from. It knows all the steps. So I can tell the system, oh, you know all the steps, and you also know how to create workflows, right? You know how to write code because my system is reflexive. So why don't you do that? And yeah, I can do that. I'm in any resource that I've created, I can click this magic button that's Scriptify, and this is running a WSML script. This is running a workflow that creates another workflow that will reproduce what I just did. So this is a nice example of how powerful things become when you can meta-program, when the same thing, your workflows are themselves resources that are manipulable using the language. So, and I'm finishing, just 2 slides. Sorry, I'm late. But just, I've been talking all these slides about workflows like chore things, like I need to combine this with that, and I want to repeat that 100 times, and okay, this is solving me lots of headaches. But it's even more powerful, which is already really powerful because it's saving time and it's saving work. But it's even more powerful than that because when you think of machine learning algorithms, most of them are just these kind of things. Are just a thing where you start with data, you select some of that, you sample it, you create a bunch of models, you start evaluating your results, you compare what you have with what you want, and then maybe you use other machine learning to look for other parameters. You look at your result. Are you happy? Yes, I'm happy. No, I'm not happy. I start over. And then I loop, and I do another loop. So most of, if you think of it, most of the machine learning algorithms that we've invented are just like loops, are a bit like chores, like workflows, like looping and looping again. And let me tell you, WSML, since it's a domain-specific language, is very good at looping. So we discovered, well, we had that in mind when we created it, that it was very powerful and that we could create new algorithms using that language. And in the same way that I can create new algorithms using WSML, of course, all of you can create new algorithms. But what's better if Basil creates a new algorithm and puts it there in the server, since it's in a domain-specific language and it's there, Stephanie can use it. And then we can grow the platform like together and add these new black boxes, like new buttons that are created by everyone. And this is an example of what I'm telling. For those of you that know what that means, hyperparameter optimization is just the idea that I had this data and I created a model, a tree, but I have like 20 possible types of models. And also when I create the things, I can put parameters there. Like if I'm creating an ensemble that it's a set of trees, I can tell how many trees I want there. Or there are lots and lots of parameters that I can fine tune. But what are the good parameters for my data? And actually, what's the good algorithm for my data? Turns out that depends on your data. So you cannot say universally, oh, this is going to work for all data. For some data sets, it's going to be a deep net. For others, it's going to be a tree. For others, it's going to be an ensemble. Moreover, sometimes, oh, maybe the deep net is just 100% better than a tree, but it takes 2 days, and a tree takes 2 seconds. So maybe you are willing to pay a bit less performance for the time, and so on and so forth. So the idea of hyperparameter optimization is that I'm going to tell you what's the best model for your data, and in order to tell you, to find out, I'm going to use machine learning. So I'm going to take your data, or a sample of your data. I'm going to start with a set of parameters and algorithms. Like, I'll try a deep net with those parameters, and I'll try an ensemble with those parameters, and I'll try a tree with those parameters. I'm going to see the results. I'm going to evaluate the results, and then I'm going to build a model that tries to predict what are the errors in my models, taking as inputs the parameters. So if I have a model that predicts the errors, knowing the parameters, I can then find the parameters whose prediction for the errors are smaller. So, and I keep doing that. And then I do another round. And then I have more information, I have more inputs, more errors, and I can improve my model. Typically, a model that you use to predict the errors is a Bayesian parameter optimization model. And you do it over and over again. So we did that. And this is something that you can do with WSML. And this is something, and I promise that I'm finishing. This is something, so what we wanted that. We wanted to give you in the platform something that is, okay, give me your data and I'll tell you the best model. And so we thought, wow, now we have to go to the back end and then program all these algorithms and do all that. But wait, if we had WSML, we could program that in a very abstract way. Like forgetting, we can also forget about errors, about parallelization. WSML will do that for us. And so we can concentrate only in coding that loop. And the complicated thing, those of you that know about a bit more about hyperparameter optimization know that it's not that easy. I mean, it's a complex algorithm. That complicated thing in WSML with comments was this long. Our first implementation, which we call it Smackdown. So if you've been in programming for a lot, you are too young. But if you've been programming for a while, you should be impressed. Like only this code working, already doing something this complicated. Well, we were very happy, and it speaks. Just believe me, it speaks a lot about the idea of not of this language, about the idea of having a domain-specific language on the server side for creating algorithms. And then once we had this working, all we had to do was to go and provide a new resource, which is that Optimal that I was showing you. We called, instead of hyperparameter optimization, we called it Optimal. And I was creating one when I started. So this is the result. This is something that has been running while we were talking, or I was talking. So see, this has done just what I told you. It's been trying lots of models, lots of ensembles, deep nets. These are only the survivors. It evaluated like hundreds of models. It created lots of resources, and finally selected the best ones. And it's telling you what's the best model to use for your data. And for instance, in this case, you would discover that it's better to use a forest, which is an ensemble, much better than using a deep network. If you look at the deep network, it's in place 100 or something like that. And why that is nice to know, because the random forest takes like a tenth of the time of creation and resources than a deep net. So why would you do a deep net? So this is a nice example, or this is a way of seeing a domain-specific language on the server side in action. This behind the curtains has been running just a WSML script. And yeah, I think, no, this is sorry, just I'm done. So what I was telling about the Fassel publishing his algorithms and Stephanie using them, yeah, we got all these algorithms are resources, so you can publish them in the web or in whatever service. It's a resource, remember, a white box thing, and you can share them. Just like any resource, and suddenly your toolbox has grown enormously. And not only for doing chores, that is already important, but also for doing real machine learning and improving your solutions. So that's all for me, and as a token of appreciation, because this is like Friday evening, so you should be partying or something, not here. You can use all these things in our platform, bigml.com, like for free up to 16 megabytes. But if you use that code when you create the user, you have a subscription. I think it's 3 months, and you can use up to I don't know how many gigabytes of data. So if you want to play, just use that code when you create your user. If you already have a user, just send us an email to support and say, hey, I was there, how was very fun, and it was great. Please give me that free promotion he talked about, and we'll do that. I'll take care of that. So that's it from me. Thanks a lot.
The talk is recorded, so you don't all have to take pictures. You can actually see that online as well later. We're going to go into a 5-minute break before we go into Q&A. So if you have some questions, maybe mark them down in a coherent way for us to ask them. And then we're going to be back here in 5 minutes with questions.
So feel free to help yourself to more drinks and
absolutely
come back inside.
Get beer. The toilets are over there. If you look over there, you see like big white signs if you need the toilets. And we'll see you again in 5 minutes.
Don't run away.
Yeah.